This week's module will be covering chapters 3 and 4 in the textbook. Chapter 3 will focus on probability. And although the textbook considers this chapter to be optional because it's possible to understand and apply the methods that we'll see in the later parts of the course without covering this material, it does provide a strong theoretical foundation for these methods that are introduced later in the course. Section 3.1 will define probability and learn some basic properties of probability. In section 3.2, we'll focus on conditional probability. Section 3.4 will discuss random variables and their distributions. And finally, section 3.5 will discuss continuous distributions. Section 3.1, when we're defining probability, we'll see that probability indicates the likelihood that a random outcome will occur, and ranges from 0, which would indicate that an outcome is virtually impossible to occur, to 1, which indicates that it will certainly occur, definitely will happen with a probability 1. We'll talk about how to calculate the probability that if we have two events A and B, that either A or B, or possibly both of them, occur. We'll also look at how to calculate the probability that A and B both occur together. And we'll talk about the complement of an event. If A is an event, the complement of A means that A does not occur, and how to find the probability of the complement. We'll also in this section talk about the idea of independence. If I have two outcomes that are independent, what that means is that knowing the outcome of one event does not change the probability of the other outcome. In section 3.2, when we talk about conditional probability, we use the notation the probability of A, and then the vertical line we think of as saying given that B occurs. And really what that tells us is it tells us the probability that A will occur if we know that B definitely does occur. So conditional probability is what we use when we're trying to find the probability of if-type statements. We'll distinguish between marginal probabilities and joint probabilities. Marginal probabilities are the same as conditional probabilities, the probability that A will happen if we know that B has occurred, versus joint probabilities, which are not conditional and are just looking at the probability that A and B will occur together without knowing for certain whether either of those occur. We'll also look at tree diagrams, which are a useful tool for calculating probabilities. And we'll see something called Bayes' theorem in this section. Section 3.4 will focus on random variables. There are two main types of random variables, discrete and continuous, and we'll learn how to distinguish between them. And then we'll look at probability distributions and learn how to calculate the mean or expected value of a discrete probability distribution. We'll also see how to calculate the amount of variation we'd expect in a random variable using the variance and the standard deviation for discrete probability distributions. And although we don't see how to do it, distributions of continuous random variables will also have means and variances. However, we would need calculus in order to find them, and so since calculus isn't a prerequisite for this course, we won't be calculating them, but it is possible, and we'll see how to do it in the discrete case in section 3.4. 3.5 introduces a little bit about continuous distributions. When we're working with conditional distributions, the key thing that differentiates them from the discrete ones is that instead of finding the probability that the random variable takes an exact value, we find the probability that the random variable takes a value within a particular interval. And in fact, the probability that the random variable takes any exact value will be 0. So for discrete distributions, a probability of 0 means that the outcome is not possible. For continuous distributions, in fact, all exact values have probability 0. So a probability of 0 doesn't indicate that something can't occur. It just means that that exact value is extremely unlikely to occur. We'll see more about this as we go into section 3.5. In chapter 4, we're going to look at distributions of random variables. We are going to look at just 2 of the distributions in this chapter. The first one in section 4.1, we'll look at normal distributions. And we'll also cover section 4.3, which talks about binomial distributions. If you have a real interest in probability and you have some extra time, feel free to explore the other sections of these chapters that we're not covering, but you won't be tested on them and the homework won't cover them. Normal distributions are bell-shaped curves that we've probably all seen before. We define them by using their mean and their variance. There's one particular normal distribution which has a special name. It's called the z-distribution or the standard normal distribution. And it's the one that has a mean of 0 and a standard deviation of 1. In this section, we'll learn how to use technology or a table to find areas in tails of a normal distribution and how to find percentiles of a normal distribution. And there are some calculator videos in there for the TI and for the Casio that you'll be able to look at in My Open Math to help you with doing some of these calculations. If you have a different type of calculator that you're working with, feel free to go into YouTube and just search for the type of calculator that you have in a normal distribution, and you'll be able to learn how to use your calculator if it has a normal distribution family in there to do calculations. If you find that you don't have an ability to do that with your calculator and you're looking for an online applet to use, let me know and I'm happy to post a little video showing you how to use an applet called StatKey that can be helpful. And then section 4.3, the binomial distributions. These are a discrete type of distribution, not continuous. It's a useful model to use when we have a fixed number of independent trials, n, and each trial has 2 possible outcomes, which we could call success and failure. And the probability of success, which we call P, is the same for all trials. So for instance, if I were going to flip a coin 50 times and count the number of heads, since I'm counting heads, heads is what I'm going to consider to be a success. The probability of success should be about 1/2 for all trials. And I've got a fixed number of trials. Each flip is a trial, and I'm going to be flipping n equals 50 times. Right? So binomial distributions can be useful in when these sort of situations come up. The random variable in this situation would be the number of successes out of the n trials. And that's what has the binomial distribution. We'll look at how to calculate probabilities with binomial distributions. And we'll also learn how to find the mean and the variance of binomial distributions. And we'll see that under certain conditions, the binomial distribution can be well approximated with a normal distribution. And that would be only if our n times p, so the number of trials times the probability of success, and n times 1 minus p are both at least 10. Then it's reasonable to use that binomial distribution approximation. So those are just a little sort of preview of what to sort of look for and expect as you're working through the material this week. Okay, so before we go, just to remind you of the things that we have to do this week. Wednesday night, the week 2 discussion board assignment is due, and that is written up in the course materials tab, so make sure you check that out. On Friday night, the week 2 R-Lab is due at 11:59 p.m. Eastern Standard Time, so that's also posted and ready to go. On Sunday night, the homework for chapters 3 and 4 is due in My Open Math. And finally, coming up test 1, which covers the material in these first 4 chapters that we've seen, needs to be taken between May 31st and June 2nd. So I'll post a reminder about that later in the week, but just to kind of keep that on the horizon, that is coming up soon. If you find that you have any questions, don't forget that I will always answer questions if you post them on the help discussion board, so that is there for you. But I also have my regularly scheduled office hours from 9 to 10 a.m. on Tuesday and Thursday that you're welcome to attend. Just join the meeting in Teams. The other thing you want to remember is that if for some reason you need to ask some questions and you're finding that you can't make it to the regularly scheduled office hours, if you send me an email, I am happy to schedule another time. And I hope you have a good week and are enjoying your Memorial Day. Thanks.